our next session titled Digital Health Environment, including Predetermined Change. Digital health continues to be one of the most rapidly evolving areas of device regulation, so we wanted to focus some time on it here today. Here to share his perspective and to get us up to speed on the subject is Alex Smith, Director of Regulatory Science at Hogan Lovells. As a former process and software engineer at GlaxoSmithKline and Human Genome Science, Alex's primary practice at H&L involves assisting companies with medical device and pharmaceutical submissions that include software, such as AI/ML submissions and 21 CFR Part 11 concerns. During his time at Hogan Lovells, Alex has provided software architecture and lifecycle advice on a substantial variety of devices, such as AI radiological imaging, 3D adaptive manufacturing, infusion pumps, and individualized vaccines involving AI. When it comes to digital health, he's in the know. Please join me in welcoming Alex. I think any of these.
Hello? We lost a big part of the crowd. I hope it's not me. So what I'm going to talk today is about regulation of software as a medical device. As Chris mentioned, I'm a software engineer. I work for Human Genome Sciences, programming in Java and C++. These days, I do software consultancy at the law firm of Hogan Lovells. I do a lot of brain interface devices, radiological imaging, things like that. And I provide architecture advice and things like that. I probably work on about 510K per day, and I'll just give you my experience with that. My experience is with the software, not with clinical trials, so don't ask those types of questions. All right, so I'm going to give an overview of FDA regulation of software, overview of artificial intelligence and machine learning, a little overview of the predetermined change control plan, our experience with that, and briefly touch on good machine learning practices. So first, FDA regulation of software. So how does FDA regulate software? So any product or software function may be regulated by FDA if it's an instrument, apparatus, implement, machine, contrivance, implant, in vitro or component that is recognized in the USP, intended for use in diagnosis of disease or other conditions, or intended use in the use of cure, mitigation, treatment, or prevention of disease, and intended to affect structure or function of the body. So the important thing here is the intended use. We all know that the 21st Century Cures Act update sort of outlines software functions that are no longer subject to FDA regulation. If they're intended for administrative purposes, health and wellness, electronic health records, medical device data systems, and clinical decision support software. And as you all probably know, there's a lot of guidances for each one of these. I'll tell you just personally, one of my big projects or kind of routine projects right now is companies have EHR systems or MDDS, medical device data systems, and the software engineers start gold plating the software. They start running algorithms and inputting CT images and things like that. And it starts becoming a regulated device. It's probably one of the biggest issues that we're coming into these days. So what are the regulatory pathways for digital health software? The first is it's not a medical device, and we'll get into that later. Subject to enforcement discretion, actively regulated, or regulated as part of a combination product. An example of one that I'm working on right now, company has AI software that does genotype prediction for peptides, and those peptides are then translated into individualized vaccines. So that's kind of an example. As we know, FDA regulates the software by risk. I'm not going to get into this due to time. But one of the big questions is about enforcement discretion. So, helps patients self-manage their disease or conditions without providing specific treatment or treatment suggestions, automates simple tasks for professionals, such as prompting, prescribing medical care, communicating with their health provider, performing simple calculations such as BMI. Some examples include software for environmental conditions for asthma, GPS tracking, video games to motivate patients to do their physical therapy exercises. One of the more regulated ones we're working on at the moment is software that helps ADHD medication for children, helps them focus their attention. That is actually a regulated device. Software functions that provide historical trending and comparison of vital signs. Software functions that remind patients of medications. General wellness. This is often, we get calls from clients, usually college students who have developed an app, and they want to know if their device is regulated or not. So there's enforcement discretion for 2 categories of product intended for general wellness. Maintaining or encouraging a general state of health or healthy activity. Associates a healthy lifestyle with helping to reduce the risks or impact of a disease or condition. And generally, this is low-risk products that cannot be invasive, pose a risk to user safety, raise novel questions of usability, or raise questions of biocompatibility. Some examples: product plays music to relax an individual or manage stress. Software app tracks caloric intake, helps users manage an eating plan to maintain a healthy weight. So those are general wellness. But as you all know, there's guidances for each one of these. There's a wellness guidance, there's a clinical decision support guidance. They're all out there and they'll help you navigate these things. All right, so getting into AI and ML. This has been probably the largest part of my practice lately. We're doing a substantial amount of radiological imaging AI software, heart software that monitors ultrasound, FFA, ejection fraction. I mean, it's all over the place now. Chris Phillips with EEG recordings from the brain. So, repeating, software incorporating AI and ML has become an important part of an increasing number of medical devices. Just 2 weeks ago, there was an executive order that everybody probably saw on safe, secure, and trustworthy artificial intelligence. Section 8 is assessing the effect of AI on multiple sectors, including healthcare. One of the big discussions around this was generative healthcare and LLMs and things like that we'll get into in a second. Let's skip over this one. So today, the regulatory framework is about the same. I will tell you, like, we've submitted AI software to almost every division at FDA, and they all seem to have their own interpretations. There are certain divisions, such as the PCCP group, that seems to be reviewing all the PCCPs. All the cybersecurity seems to be coming out of the cybersecurity consultancy, but generally each division seems to have their own set of questions and their own set of interpretations of what the guidances look like. Honestly, we see different questions from the reviewers on different submissions, maybe 2 months later. You know, you get a new cycle of 25-year-old reviewers come in and they have a new set of questions. So whatever you see in your predicate, don't necessarily expect to see in the follow-up. When we get these, you know, we'll go to FDA and we'll say, here's what the predicate did. FDA will tell us, oh, this is FDA's current line of thinking. That's a common statement from them. Current state and recent clearances, at the moment, as far as I know, only locked algorithms have been cleared. One of the common requests is about, we have an LLM that connects with ChatGPT or one of the other ones, and we want to have a large LLM that does clinical decision support. FDA doesn't seem to be going for that at the moment. I can't see them moving forward from that at any point. FDA clears specific indications, not platform technology. We have a lot of clients that come to us. We have a platform that scans all these indications. We want to get it cleared as one device. FDA doesn't seem to allow that. They want one indication at a time. Previously, we were doing de novos quite often. Now there's a tremendous amount of 510Ks coming out, especially for CT, radiological imaging, things like that. Clinical data is supporting pretty much everyone that we're submitting at the moment. Not to say that it isn't, but that's what we're seeing. Historically, there was a lot of breakthrough designations, but we're not seeing a lot of those anymore. As we know, CDRH published the Artificial Intelligence and Machine Learning Medical Device List. We've been seeing that. I think that gets updated once a year, every 2 years, something like that. So you can look for your predicate. I don't know if this is large enough. This is a nice slide that I found. It shows a number of examples that are out there with cardiology, endocrinology, radiology, neurology, internal medicine, ophthalmology, emergency medicine, and oncology. We're seeing a tremendous amount of like diabetic retinopathy devices these days that are looking through the camera to see what diseases you have in the eye. But it's really kind of exploding, and we all know that. Some recent clearances, Kiameds, worked on static coronary CTA images, Cognoa, which was used for healthcare providers in the diagnosis of autism spectrum disorder. So what is FDA looking for? The ground truthing process. I mean, generally, FDA is looking for the 2-in-1 philosophy. So 2 clinicians with 1 agreement, and we're kind of seeing that across the board. They want to see separate training and validation data sets. This is pretty well laid out by the EU and FDA. MHRA, Health Canada, they've all come to an agreement on this. Trading data details need to provide to FDA. It needs to be geographically diverse in the US with 3 sites typically required. Retrospective data sets can be used for different indications. The subgroups assessed and needed to be powered for discern analysis. And I'll skip over the last one since that's not my area. All right, so predetermined change control plans. I think I was lucky enough to work on the first 2 that were cleared. Overall, I think we've done about 3 of them. I'm not sure how many in total are out there. So FDA issued the AI/ML PCCP draft guidance on April 3rd. Recognition that by FDA, the software products are intended to be updated on a regular and frequent basis. The potential allows more frequent and continual optimization of algorithms. Innovative approaches are needed to change to support the iterative nature of software as a medical device. And I'll get into a few examples of what these changes include in a second. So the goal of a PCCP is part of a marketing submission intended to provide a means to implement modifications to machine learning-enabled device software functions. So what does this allow you to do? It allows you to make changes to your software after your initial clearance. A lot of this involves, actually, let's get into the next slide. That's probably better. I'll move that to a second. So the FDA draft guidance on PCCPs, we always recommend early engagement. A pre-submission is recommended, a pre-submission meeting. The review division will determine whether the scope of modifications is appropriate for inclusion. Let's get into this. Okay. On October 23rd, just a few weeks ago, FDA, Health Canada, and MHRA released the PCCP Guiding Principles document. They want the PCCPs to be focused and bounded, risk-based, evidence-based, transparent, and within a total product life cycle perspective. Is this big enough? All right. So some of the information that FDA wants to see in these PCCPs for AI, modifications related to quantitative measures, modifications related to the device inputs, limited modifications to the device's use and performance. They want the company to outline the data management practices, the retraining practices, performance evaluation protocols, and the update procedures. So some examples of cleared PCCPs, Caption Health's caption interpretation automated ejection fraction software, that's a lot. Also, Medtronic's insertable cardiac monitor. I would look at 2 of these. I will tell you FDA has kind of moved on from these 2, though. So some examples. No change to the intended use to device. No change to the input type. No change to the output type. Performance and modification can be completely evaluated by the original test methods. Some examples of potential changes: training on additional data, optimizing hyperparameters, changing the number of layers in the neural network, changing the type and parameters of layers, changing connections between the layers, changing predictors in the algorithms, changing the loss function, pre-processing, user weight, and activation measures. I will tell you, a lot of this depends on your relationship with FDA, though. I'm going to get into a few examples where we've had FDA pull back on the PCCPs right before a clinical trial or something like that. So here's some example comments that we've received on PCCPs. So change on the algorithm model type. So CNN or support vector. Change goals, this is an FDA comment. Change goals should be specific and verifiable, and a different regression algorithm does not provide sufficient detail to understand what changes you intend to implement. So if you have a particular algorithm in mind moving forward, say from ResNet to EasyNet, FDA will want to understand what your intent is moving forward. I actually would recommend that you do this under another 510K, to be honest. Demographics and weighting. FDA said, we're concerned that your constraints for adjusting the training data set do not confer the same assurance that the revised data set will be representative of your intended use population. And the last one, which I mentioned before, we are rescinding the current approval of the PCCP and request that all modifications to the algorithm or software are submitted to FDA through the regulatory process. Now, this happened when the company had their pre-approval inspection. FDA came out and found out there was a lot of gold plating, things that were classified as bug fixes weren't bug fixes. They got a letter from FDA saying, we're taking this back. We want you to fall back to your original algorithm. All right, and coming up to the end here, some GMLP guiding principles. How are we doing on time? A little rushed. So as you know, FDA put out there, or with Health in Canada, US FDA, and MHRA, in October 2021, they proposed 10 principles for good machine learning practices. And we'll see how this evolves in the coming future. So they want multidisciplinary expertise, good software engineering and security practices, clinical study participants and data sets are representative of the intended use population. Training data sets are independent of the test sets. Selected reference data sets are based upon best available methods. Model design is tailored to the available data. Focus is placed on the performance of the human AI team. Users are provided clear, essential information, and deployed models are monitored for performance or retraining. Just coming up to the end here. So software modifications. There's a guidance that some of you are probably aware of, when to submit a new 510K for software changes. The big thing for software engineers is making changes on a daily basis. You know, what is a bug fix and what is not a bug fix? That guidance, when to make a software change to a device, outlines a number of changes such as infrastructure, architectural changes, things like that. Essentially, you want to move it into your original specifications. That's acceptable. A change that introduces a new risk or modifies an existing risk that could result in significant harm would be a new 510K. Changes to risk controls to prevent significant harm, that could be a new 510K. A change that significantly affect clinical functionality or performance specifications, likely a new 510K. So from my perspective, bug fixes are minor modifications that do not affect the algorithm's output and performance. Things such as cybersecurity, code errors, communication faults, and things like this. One of the big trouble that companies are having now is, you know, when they deploy their software to thousands of hospitals throughout the land, how do we track all those changes, IP addressing and things like that? Do it by risk. All right. So I think that's about it. Thanks for letting me come out today. Yep. I have some questions. No, they definitely won't. I mean, honestly, like TensorFlow, PyTorch, commonly used, right? They don't, FDA will not give you any suggestions for what to use. Yeah, absolutely not, yeah. You just have to justify whatever you're using. Yeah, as long as it sounds reasonable and they have their checklists for keywords. As long as you hit those keywords, it'll go through in my perception. Yeah. Do you mean like what type of CNN algorithms? Or, I mean, honestly, like ResNet is probably the most common. Yeah, the number of layers differs from device to device. I've seen everywhere from 6 to 50. So it really doesn't matter to FDA as long as you explain it fully. Yeah. Any other questions? Do you want to touch on cybersecurity a little bit?
You had a couple examples of devices that have been cleared or gone through
Yeah.
the NOVA process. Are there other recent examples out there that are closer where FDA is aligned right now?
Do you mean for PCCPs?
Yeah, or just AI.
Well, I will tell you Caption Health has gone through 3 PCCPs at the moment for different indications for hard software, ultrasound, FFA. Maybe we'll wait. Eric Henry will come up in a second. Maybe he can give some more examples from his perspective. Yeah, yeah. Well, yeah, thanks for bringing it up. Sure. So as we all know, there's the new cybersecurity guidance. FDA wants you to do a threat model, risk assessment, provide the SBOM. I do recommend Microsoft has a nice threat model tool on their website. I've actually built one in about 5 minutes for a client who insisted on submitting that afternoon. That tool will help you build it in about half an hour for your full device, as long as you know the architecture well enough. FDA they want to make sure that you're doing the end-to-end process. A lot of companies don't consider that. If you're installing it in a hospital environment, they're very keen on the end-to-end. They want you to understand the full architecture of the hospital and what your trust boundary is around it. That's about it. One of the more things they're asking for now, the SBOM that's now required, software bill of materials. They want to understand all the OTS and software libraries used in the software. We're receiving some mixed messages from FDA. Some clients are providing the SBOM as a JSON file, for all the API. Some reviewers are saying this isn't acceptable. They want to see a paper SBOM. So we're getting some mixed messages about it, depending on the review division. Well, SBOM, software bill of materials, it's a list of all the off-the-shelf software, libraries, and things like that, such as a Bluetooth driver or Amazon Web Services, big to small. Everything that is in your software. Yeah. Yeah. Honestly, it's been a little challenging. We're generally in the cyber plan, which is required, we outline how we're going to handle updates and things like that to the OTS. And then the SBOM will be a separate electronic document. They want you to assess the vulnerabilities associated with everything in there. You can do that with tools. Gripe is a very popular one. It'll scan your SBOM and tell you if you have any vulnerabilities associated with it. GRYPE. Yeah. Yeah. It really depends on the risk for each one. You know, we've had some clients who've had 200 bug fixes in a year, right? And they think each one, this is a really good question, and they think they've assessed each risk is very low. They've done a change control for each item. But then at the end, FDA's gone in for an inspection and had major issue with it. There's a public warning letter for BD you can look at. Yeah, but it's a good question. It really depends on the scope of what the bug fix looks like. Yeah. But if you start seeing a trend, I would open up a CAPA and assess that all in one. Yeah. Any other questions? How are we doing on time? Yeah. Yeah. Sorry, is this this camera for colonoscopy? AI looks. Oh. Oh, gotcha. Okay, sorry, misheard. Yeah. Sorry. Yeah. 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 It always depends. Yeah. That's a little tough. We usually do like a proper regulatory analysis. I don't want to say on the stage, but I'm glad he said it depends. Well, thanks for hosting me up here. I was a little nervous, so I appreciate it. Thank you.